Hello everyone. Today we are going to see about Laplace transform periodic function type 3. In the previous video I have explained you about type 1 and type 2 problems. Now we are going to see type 3 problem. This is the periodic function L of f of t is equal to 1 by 1 minus e power minus as 0 to a e power st f of t dt. We are going to use this formula in this problem and we are going to find the Laplace transform of the given function. Let us consider this question. Find the Laplace transform of f of t. Function t for the interval 0 to a, the function is t, and for the interval a to 2a your function will be 2a minus t. In type 1 problem, our f of t, that is f of t is a constant for the k constant for the interval 0 less than t less than a and a less than t less than 2a. Both of the functions were constant for the given intervals. The next type 2 had a little change only in the interval, that is a by 2, just a by 2. Now the type 3 problem, you have a variable, there is no constant, you have a variable in this function. This is the difference in this type 3 problem. Now let's solve this problem and find the periodic function for the given problem. Let us first write the L of f of t. L of f of t, which is equal to 1 by 1 minus e power minus a. A is the highest interval, that is highest limit given in the problem. Here highest limit is 2a. So I am writing minus 2as integral 0 to the highest limit in the given problem is 2a. So I am writing 2a here. Next e power minus st f of t dt. In the next step, we are going to split this integration and we are going to write the function for the given interval. 1 minus e power minus 2as integral, let us open a common bracket, set bracket, 0 to a, the first interval. For the first interval, the function is t. E power minus st is already there in the formula. The next function t, next dt, plus the next integral a to 2a, a to 2a, e power minus st is already there in the formula. Now the function is 2a minus t into dt. Now in the next step we are going to apply the Bernoulli's equation. In the next step we are going to use Bernoulli's formula to simplify this step. The Bernoulli's formula is integral u dv is equal to u v1 minus u dash v2 plus u double dash v3 minus etc etc. Here u is the differentiating value and v is the integrating value. Either you can take e power minus st as u or t as u. Have a note, if you take exponential, logarithmic term and trigonometric function as a differentiating value, you will not get 0. So always take a variable for differentiation. Have a note, if you take logarithmic functions, exponential functions and trigonometric function as the differentiating value, you will not get 0 in 1 or 2 steps. But if you take a variable, the variable will become 0 while differentiating in a first step or a second step. So it will be easy for you for simplification. So to make it easier, we are taking the variable as u. Now let us take, here we are going to take in e power minus st integral 0 to a e power minus st t dt is here. Here I am going to take u is equal to t, which is a variable, and v is equal to e power minus st into dt. Here u, while differentiating u, we will get 1, and again if you differentiate you will get 1 will become 0. The next step, here while integrating v1 we will get e power minus st by minus s. Again if you integrate this you will get e power minus st by s square. The next integration we are going to take, that is integration of a to a e power minus st 2a minus t into dt. Here also we are going to take the variable as the differentiating value. U is equal to minus 2a, u is equal to 2a minus t, and v is equal to e power minus st dt. Now u dash will be, this is a constant so it will become 0, minus t is minus 1, u double dash, that is differentiating the second order, you will get 0. v1 integrating, while integrating e power minus st into dt, e power minus st by minus s. v2 is equal to e power minus st by minus s square. v2 is, again we are integrating this value, we will get this one. Now we are going to apply this 2 in the Bernoulli's formula and we are going to get the desired results. L of f of t, which is equal to 1 by, here is that 1 by 1 minus e power minus 2as, while we are going to apply Bernoulli's formula in this place. So u v1, u is t and v1 value is e power minus st into divided by minus s. So common bracket u into v, that is u is t, v1 is e power minus st by minus s. Here is a minus sign, u dash value is 1, 1 into v2 value is e power minus st by s square, 1 into anything will be the same, so e power minus st by s square. The limits are 0 to a. I am not applying u double dash v3 because u double dash is 0, while multiplying 0 into anything will be 0, so I am leaving it. I am moving on to next one. Here is a plus sign, I am writing plus here. The integration value is, we are going to apply the Bernoulli's formula, u into v1, that is u value is 2a minus t, 2a minus t into v1 value is e power minus st by minus s. Here is a minus sign in the formula, so I am writing minus. Next u1 into u dash into v2, u dash value is minus 1, v2 value is e power minus st by s square. There is a minus sign, so this minus and minus becomes plus e power minus st by s square. The limit is a to 2a. Now I am closing the common bracket. In the next step we are going to apply the limits inside. 1 by 1 minus e power minus 2as. Apply the upper limit a in the place of t, a into, that is t, a minus a e power minus as by minus s, minus e power st is there, e power minus s into a divided by s square. Lower limit is 0. If you apply 0 in the place, you will get 0 into anything will be 0. So I am leaving it. While applying the lower limit, you will have minus sign. So this will become 0. Next one, minus e power 0 by s square plus 2a minus, the upper limit is 2a into e power minus 2s 2a divided by minus s plus e power minus 2as by s square minus of, that is while applying lower limit there will be a minus sign. The lower limit is a, so put a in the place of t, 2a minus a into e power minus as by minus s plus e power minus 2as by s square. We are going to simplify this step. 1 by 1 minus e power minus 2as, open bracket, 2a minus a will become 0, a e power minus as by minus s minus e power minus as divided by s square, minus 0 will be 0, so leave it, minus into minus, plus e power 0 will be 1, 1 by s square, the next plus e power minus 2as by s square minus of, so minus 2a minus a e power minus as by minus s, so this minus into minus will become plus, multiply this minus here, minus into plus you get minus e power minus 2as by s square. Check for the possibility whether we can cancel any terms. Minus a e power minus as by s and plus a e power minus as by s can be cancelled. So here, sorry, while applying the lower limit e power minus, yes, you will have a only. I have written here 2. Change it. I am changing it here to e power minus as by s square. Now simplify and write the remaining step. 1 by 1 minus e power minus 2as, 1 by s square minus e power minus as by s square, and minus e power minus as by s square becomes minus 2 e power minus as by s square plus e power minus 2as by s square. Look at here, 3 of the terms have the common denominator, so let us take this constant outside, 1 by s square into 1 minus e power minus 2as. Again look at the above, 1 minus 2 e power minus as plus 1 e power minus 2as is of the form a minus b the whole square, that is a square plus b square minus 2ab. So we can write this term as 1 minus e power minus a as the whole square. Look at here, this is of the form a square minus b square. So that we can split this term into a plus b into minus a. Sorry, a plus b into a minus b. I am going to do this in the next step. 1 by a square into 1 plus e power minus as into 1 minus e power minus as. 1 minus e power minus as the whole square. Now this one this cancelled, so write the remaining terms, 1 by s square into 1 minus e power minus as divided by 1 plus e power minus as. Now multiply the numerator and denominator by e power as by 2. Multiply and divide by e power as by 2. Well, next step we are going to multiply e power as by 2 inside this term. L of f of t, which is equal to 1 by s square into, multiply e power as by 2 inside, 1 into e power as by 2, e power as by 2 minus e power as by 2 into e power minus as. Next we are going to multiply e power as by 2 in the denominator. E power as by 2 plus e power as by 2 into e power minus as. By the power rule method, e power n into e power n will be e power m plus n. So we are going to apply this power rule method in this place. Here the powers m and n are as by 2 and minus as. So as by 2 minus as. Both do not have the same denominator, so we are going to take LCM, as by 2 minus as. As minus 2as by 2, so you will get minus as by 2. L of f of t, which is equal to 1 by s square into e power as by 2 minus e power minus as by 2, e power minus as by 2 divided by e power as by 2 plus e power minus as by 2. And this is of the form e power, we know that e power x minus e power minus x by 2 is sin hx. So we can replace sin hx in this place. 1 by s square into e power x. In the place of x you have as by 2. So sin h, in the place of x you have as by 2, and this 2 goes there, so we get 2 sin hx divided by similarly e power x plus e power minus x is 2 cos hx. So we replace this term by 2 cos hx. 2 cos, in the place of x you have as by 2. We all know that sin by cos is tan. 2 to get cancelled, sin by cos is tan. So we are replacing sin by cos as tan h into as by 2. This is the Laplace transform of the given periodic function. Hope you understand. Thank you.